Z1 is a present value random variable for whole life insurance of 5 on age 40, benefits payable at the end of the year of death. Z2 is a present value random variable for a 10-year term insurance of 10 on age 40 with benefits payable at the end of year of death. We can use a standard ultimate life table, 5% interest. And we want to find the covariance of Z1 and Z2. So using first principles, the covariance is the expected value of Z1 and Z2 minus expected value of Z1 times expected value of Z2. Well, let's see what Z1 is. Z1 is a whole life insurance of 5. So the present value is always going to be 5 regardless of what year it is. So we can say for the first 10 years or after 10 years. Z2 is a present value random variable for a 10-year insurance of 10. So it's going to be paying 10 times the present value, so the discounting factor, for the first 10 years. And it's not going to pay anything after the 10 years. Okay. So I should also say that this is really K40. So we're discounting it, or we're paying it at the end of the year of death. That's why we should add the +1 there. Okay. All right, so now we would look at the first term here. We're finding the expected value of Z1 times Z2. So we should multiply Z1 by Z2. Okay, so let's look first when k sub 40 is less than 10. So we have 5v to the k40 plus 1 times 10v to the k40 plus 1. So 5 times 10 is 50, and we're going to add the two exponents. Okay, and then Z1 times Z2, when k40 is greater than or equal to 10, 5v to the k40 plus 1 times 0 is just 0. So let's look at expected value Z1 and expected value Z2. Okay. Well, expected value Z1. Z1 is a whole life, so that's just going to be $5 at the time of death. Z2 is a 10-year term insurance, so that's going to be 10. It's going to be payable 10 if the person dies within 10 years. Now we want to look at the expected value of Z1 times Z2. So that's 50, but here we have a 2 here. So that's where we're basically doubling, or not doubling, but squaring the discounting factor. So that's the same thing as 2A40 angle 10. And this is a 10-year term insurance when we multiply. But because there's a 2 there, we have to put the 2 over here. Okay, so now we can simplify this. Well, I can write it as 50 times 2A40 minus 10E40, but because there's a 2, we have to use 2 as well for 2A50. So for the 2E40, we can represent that as V10 times 10E40 times 2A50. And we can grab all the information from the standard ultimate life table to get 0.21831. Now for the expected value of Z1, we said it was 5A40. So A40, if we look it up in the table, is 0.12106. So that's just 0.6053. And we look at the expected value of Z2. We said that was 10, and it pays out 10 if the person dies within 10 years. So we can represent this as a endowment subtracted by a pure endowment. So for these, we have all the information from the standard ultimate life table. So we copy these down, and we get that it's 0.0574. So all along we wanted to find the covariance, Z1, Z2, and we said that was the expected value of Z1, Z2 minus expected value of Z1 times expected value of Z2. So plug it in. And we get the final answer is 0.1836.